Alright, ladies and gentlemen, this is our third set of notes for this unit, which is we're moving a little bit away from the whole motion and the graphing aspect of it, and we're going to talk more about motion and forces, which basically talks about why does certain things move the way they do. Like, why do some things speed up? Why do some things slow down? So that's what we're going to be talking about when we talk about forces. This is probably going to be the most important set of notes in regards to the car project when determining what kind of supplies that you want to bring in for school, the causes of what makes your car go faster, what makes your car go slower. So this is going to be a big presentation for that. Alright, so let's start up. So the first thing is vocabulary. The main vocabulary is obviously what we're talking about right now is forces. Alright, so that's going to be, so basically what a force is a push or a pull, right? That changes an object's motion, right? So whether it's changes in one direction or that kind of stuff. And it has two things. It has a direction, so which way are you pushing something or pulling it, and how strong, magnitude, you're pushing or pulling that object. Okay, and it's measured in newtons. And the way you write it, as you can see right here, is it looks very similar to velocity, except for the fact that it has n instead of meters per second or miles per hour. It's got to have the strength. So 5 newtons is the strength part, and then which direction? East, left, right, up, down. So that's kind of how you would write force. Okay, so what we're going to go over in the next few slides are about just like what are the different types of forces that are out there. So, a way an object is pushed or pulled, there's different ways that things can get pushed or pulled. So the first one, this is the most common one, okay, which is called an applied force. Okay, like I said again, it's the most common. So it's when an object or a person just physically pushes something. So like, as you can see, a person pushing a box. There's one example, a car accident, right? One car hits another car. So in other words, the car is pushing another car. That's the reason why there's damage. So that's applied. There's all these other things. Like, for example, when you get up out of your chair, when you push your seat backwards, that's an applied force. Right now, you're writing something. The pen is pushing on the piece of paper. So that's an applied force. Okay. The next one is gravity. This is the one that it's hard to tell because you don't actually see physically something pulling on it, but anytime you throw something in the air, what happens? It always comes down. And the reason why is because the earth is pulling the object down. You don't see it. It's a non visual pull, but it happens. That's the reason why whenever you go up into space, you see people floating, because now all of a sudden something isn't pulling on something. Like here on Earth, we have the Earth pulling us downwards. Alright? And then there's buoyant force. The buoyant force is dealing with liquid. So unless there's a liquid, you can't have a buoyant force. Alright? And it's an upward force that a liquid pushes on an object. So what usually happens is, for example, let's say ice, right? We all put ice in our liquids, in our sodas or drinks or something like that. What happens? It usually floats. And the reason why it's floating is because the liquid is pushing up on the ice, and that's what makes it stay afloat. Now it doesn't keep going up because gravity is also pulling it downwards too. So you see that the buoyant force is always pushing on it. So like even if something stinks, there's still a buoyant force that's going upwards. It just means that gravity is actually pushing the object down stronger than the liquid pushing up on it. And that's the reason why certain things sink. But we'll talk more about that Unit 3. Unit 3 is more about buoyant force and stuff. Okay. Tension. These are tricky because this next slide, we're going to talk about tension and compression. All right. Tension is when something is being stretched out. So in other words, like when you stretch a rubber band. Now the big thing that you want to understand is the tension force is when pulls the object back to its original shape. So for example, let's look at the first picture. Right? The first picture shows a person pulling a rubber band, right? Most people think that tension force is where it's going outwards because you see the rubber band stretching. So you think, but that's not actually tension. That's you pulling on the rubber band. So that's actually applied force. What tension is, it's actually a force that goes back this way. Because, again, it means it's wanting to go back to its original shape. So whenever you pull a rubber band, how does it want to go back to its original shape? It's pulling back towards the center, right? So whenever you pull a rubber band and you feel it pulling against your fingers, that's tension. It's when it wants to go back to its original shape. In other words, let's look at the second picture, the balloon, right? When you blow up a balloon, what does a balloon want to do when you actually let go of it? It actually wants to go back to its original shape, which is to not be inflated. So actually, tension is more like this, right? It all goes back in. So whenever you let go of the balloon, everything compresses inwards, and that is the tension force. So it's the opposite direction that it actually looks like you're stretching it too, right? The opposite of that is what's called compression. Right. And again, remember, I'm probably going a little bit faster than the way you can write, so you want to make sure that you're pausing it as you're going along. Okay. Now, compression is when you're actually compressing or smushing something, right? And again, same as tension, the compression force of the object pushes back to its original shape, right? So whenever I push on like a spring, like whenever you're playing pinball, right? Whenever you press that spring, what does it want to do? It actually wants to go back to its original shape. Like, look, if you look at the first picture of this guy pushing it. So the guy pushing the spring is an applied force because he's physically pushing it. But what's happening is compression is where the spring wants to go back this way. Okay? So what would actually happen if you let go of it? The guy would go whee and go flying, right? And so that's what compression force is. And that's the reason why in pinball it works like that. You compress it, and then when you let go, the ball goes flying, right? Same thing over here. If you look at the guy getting hit with the soccer ball and actually his face is being compressed. Well, when they get compressed, what does the face and the ball want to do? They want to go back to its original shape. So actually, for the compression, it's outwards, all right? With tension, it's inwards, usually, all right? So they kind of go hand in hand a little bit to a certain extent. All right, so the last two that we're going to go over, these are forces that make an object slow down. It's really, really important. These are the things that are actually going to affect your car the most. Okay, so it's really, really important that you understand these concepts. So the first one let's go over is drag or air resistance. Some people call it wind resistance too. But these objects, they always, I can't even say enough, they always slow you down. Okay, so drag or air resistance, drag is basically when an object goes through a liquid. So if you're swimming, right, what would happen if you just stopped swimming all of a sudden? You would slow down because the water is actually pushing against you. If you're in a boat, right, what makes it so that the boat doesn't keep speeding up, or when it stops, when you put the brakes, not break the brakes on, but when you keep going and you turn off the engine, it's the water that's pushing against the boat. Okay, air resistance, just like what it sounds like, is when you're going in the air and when an object is going, right, and the biggest thing is when you put your hand out. When you put your hand outside of the moving car, right, what do you feel? You always feel like your hand's going backwards. And the reason why that's the case is because, you know, the car is whipping through the air, but the air is actually trying to slow you down. And that's the reason why your hand feels like it's going backwards. And that's what a car has to go through. So a car is constantly feeling like it's being pushed backwards. And that's what's going to happen to your car project is the air is going to be pushing back on your car. So you got to figure out a way to overcome that. All right? It's always going to be there. There's a certain shape that you can make your car that's going to allow for it to go through the air better. Okay? So the other one that we're going to talk about is friction. And friction is basically when two objects come in contact. So any two objects that come in contact and where one's moving, it's going to cause friction. There's going to be some like sliding and rubbing against each other, and it's going to slow the object down. Okay, this is another huge one for your car, because what happens? The wheels are always touching the ground, which means there's always going to be friction between the wheel and the ground. What you have to figure out is how do you overcome that much. There's always going to be friction, because with the car project, it's going to have to be on the ground at all times. So it's always going to be touching the ground. So you have to find a way to make it so it's a little bit better there, right? The other thing too is you want to be there's one more area that most kids don't think about. There's friction. There's one extra spot, and that's actually probably a bigger friction than the wheels touching the ground, right? So think about where your car, where like two objects are touching one another and one's moving, right? And that causes always friction. All right, again, these two always slow your object down.